Okay, here's part 2 of the video answer key for the January 2019 Regents, questions 13 through 24. From a point on the ground, 1/2 mile from the base of a historic monument. So we've got a point on the ground. We're 1/2 mile from the base of a monument. So this is 1/2 mile. The angle of elevation is 11.87 degrees. And we want to know what's the height of the monument. So we're looking for this to the nearest foot. So the first thing I notice is that they give me the measurement in miles, but they want the answer in feet. So I'm going to have to convert from miles to feet. If I look at the chart I'm given, at the formula sheet, I'm going to notice that every 1 mile has 5,280 feet. So 1/2 mile times 5,280 feet per mile is going to give us 2,640 feet. So instead of 0.5, I'm going to use 2640 here. I notice that the thing I'm looking for is opposite from the angle I'm given. And the distance at the bottom, that 2640, is the adjacent side. So according to my pal Sokotoa, opposite and adjacent is going to have me use tangent. Toa, tangent. So I'm right here. So I've got the tan of 11.87 is equal to opposite x over adjacent 2640. I'm going to put this over 1 and cross multiply. So I get the distance I'm looking for, x, is equal to 2,640 times the tangent of 11.87. Throw that bad boy in my calculator. You get 11.87, take the tan of that, and then multiply that by 2640. It gives me approximately 555 feet. So it's about 555. Okay, number 14, the area of a sector with a radius measuring 15 centimeters is 75 pi, and we want to know the measure of the central angle. So we're going to use that formula that relates the central angle to the area of the sector. The central angle over 360 is equal to the area of the sector divided by the area of the circle. We're looking for the central angle, that's x, so I've got x over 360 is equal to the area of the sector they tell me is 75 pi. I got 75 pi, and the area of a circle, according to my formula sheet, is pi r squared. So I've got pi times the radius, which is 15 squared. Make this simpler, I have pi in the numerator and denominator, I'll cancel it. 15 squared is 225, I'll just rewrite that. And then I'll cross multiply. So I've got 225 times x is equal to 360 times 75. 360 times 75, which is 27,000. Divide both sides by 225. And that gives me the measure of my central angle is 120 degrees. Number 15, we've got the partitioning problems. We want to find a point on this line segment AB that divides it in a 1:2 ratio. They tell me that A has coordinates of -1, -3. So remember, that means I'm going to have to graph this thing so I can visualize what the answer is. So -1, -3 is A, and then 8, 9 is B. I'm going to connect those 2 points with a straight edge. Make sure I get an accurate answer. Like that. I want one part on one side of m and 2 on the other. So that's going to be 1 plus 2, or 3 total parts. I'm going to count my vertical chain. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that vertical change, I want to divide it into 3 equal parts, meaning each part is going to have a vertical change of 4. So I'm going to go back to A. I'm going to go up 4, follow that horizontal line over to my line segment AB and make a point. Go up another 4, follow over to line segment AB, make a point. I want to pick one of these 2 points, right? I have 1, 2, 3 equal segments like I wanted. I want to pick one of these points that gives me one segment closer to AM and 2 segments closer to MB. So if I put it right here, I've got one segment on this part and 2 segments on this part, so it splits it up the way I want it to. So the coordinates of M, positive 2, positive 1, answer choice 1. Number 16, we got this picture drawn here. We want to know which equation is always true. This comes directly from the exterior angle theorem. So it's just testing whether or not you remember that. The exterior angle theorem, as a reminder, says if you take a triangle and you extend one of the lines, one of the sides, that the measure of this outside angle is going to be equal to the sum of the 2 remote interior angles. Remote meaning the one that's not adjacent to the exterior angle. So this angle here is equal to the sum of these 2. So we just want to see which of these applies that. And if we go through each of these, 1 is an exterior angle, 3 is a remote interior angle, but 2 is adjacent, so that's not a remote interior angle, so 1 is out. 5 is not an exterior angle, so that's out. 6 is not an exterior angle, so that's out. And so 4 is our answer, so here's why. 4 is an exterior angle of triangle AEB. The 2 remote interior angles, sorry, I take that back. I was reading it wrong. 7 is an exterior angle of triangle EBC. And the 2 remote interior angles are angles 3 and 2, just like the picture I drew. So this angle is equal to the sum of these 2 according to the exterior angle theorem. Number 17, which equation would determine the value of angle A? So what I'm given, right, I noticed that this 8 is adjacent and this 17 is my hypotenuse, and so I might be inclined to say, okay, that's a cosine adjacent hypotenuse, CA. The cosine of angle A is equal to 8 over 17, and then I look at my answer choices, and I don't see that as an answer. So do I panic? Nope. I try to think of what other tools can I use to help me figure this out. So I notice that this is a right triangle. I notice that I have 2 sides of the right triangle, so I can find the third side by using the Pythagorean theorem. A squared plus b squared is equal to c squared. So we're going to look for A. We know that b is 8, and c, our hypotenuse, is 17. We have x squared plus 64. 17 squared is 289. To solve, I'm going to subtract 64 from both sides. It gives me x squared, 289 minus 64 is 225. And square root both sides, and I get x is equal to the square root of 225, which is 15. So that means BC is a 15, length 15. So that opens up a few more options for me. I already know that 3 is wrong because the cosine we said was 8 over 17. The sine of A would be opposite 15 over 17, not that. The tangent of A would be opposite 15 over 8, adjacent, so this is wrong, and that's what makes this our answer because 15 is opposite and 8 is adjacent. So this is a combination Pythagorean theorem and trig problem. Number 18, good old Francisco. needs to complete a stained glass window using 3 pieces of glass. It can be purchased in rectangular sheets that are 12 inches wide, and we want to know what's the minimum, the smallest length of a sheet of glass that Francisco must purchase in order to have enough to complete the window. So this is a tricky question. It's one of those you can kind of either see it right away or you don't know what to do. So it's just kind of testing whether or not you can take these shapes and model something after it, if you can kind of reconstruct this and put anything together. One thing I notice is that this distance here is 6, so it makes this distance 6. And I notice that this is 12 and this is 13. So if I used the Pythagorean theorem, I would see that this distance has to be 5. So it's possible to take a triangle, actually to take this triangle and rotate it a little bit, reflect it, and throw it here and make that 5, make that 12, line up that 13, make that a nice right angle. So this triangle we can take care of by just smushing it into that little corner up there. And similarly, we can do the same thing with this triangle, because this is 15, and we have 9 units left over here, or 9 inches left over, because 9 plus 6 plus 5 is 15, is 20, excuse me. And then the height is 12 also, so that fits really nicely right there. So we can do a rectangle that looks like this, that is 12 inches wide, and it says what's the minimum length that he has to purchase to have enough to complete this window using these 3 pieces. Well, he's got the trapezoid, he's got the 2 triangles. What's the length of this rectangle? It's 20. Number 19, the diagram of quadrilateral navy. They give us a few different angle measures. And this is using a theorem that was only mentioned in passing. This is the first time it's shown up on the Regents, so I wouldn't sweat it too much. A lot of you guys were able to reason your way through it, which is great. I hope that you continue to do that. But with what we're given, we can find all of the angle measurements in these triangles. So if this is 30, that's 38. Together, they're 68. Angles have to add up to 180. So 180 minus 68 is 112, which would be the measure of angle NYA. Similarly, angle V is 94, and angle YAV is 46. 94 plus 46 is 140. 180 minus 140 is 40 degrees. So angle VYA is 40 degrees. What theorem this is using is the fact that in any triangle, the longest side is always going to be across from the biggest angle, and the smallest side will be across from the smallest angle. So in triangle YNA, this side is the biggest side because it's across from the biggest angle, and this side is the smallest side because it's across from the smallest angle. So it says which segment has the shortest length. Well, we know that NY is bigger than YA because 38 degrees is greater than 30. So that's out. Now if we use this other triangle, we know that this is 94 degrees. So YA is the biggest side in triangle YVA because 94 is the biggest angle. So AY is not our answer. VY would be the medium-sized side because it's across from the middle angle. And VA would be the smallest side because 40 is the smallest angle in that triangle. So answer choice 3 is correct. Number 20, what's the equation of a circle whose center is 4 and diameter 10? There's a couple of ways you could do this. You could trial and error, complete the square on all 4 answers, see which one gives you the correct solution. That's going to be kind of a pain in the butt though. Right, so that's totally a method that we've learned. We could try it out with one of them and see what happens just so you remember what to do. X squared minus 2x plus y squared minus 8y is equal to 8. if we want to rewrite this, that's when we'd use the box method to complete the square. So x squared minus 2x plus a box plus y squared minus 8y plus a box is equal to 8 plus a box plus another box. How do I remember what number goes in here? Well, I take this number, I divide it by 2, and I square it. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1, so I throw a 1 in there, a 1 in there. Same with this side. I'm going to take this number, negative 8, divide it by 2, and square it. Negative 8 divided by 2 is negative 4. Negative 4 times negative 4 is 16. So I got a 16 right there and right there. So when I finish this guy up, now I need to rewrite it like the equation of a circle, meaning I want to factor this thing, x squared minus 2x plus 1. Two numbers that multiply to positive 1 and add to negative 2. It's going to be negative 1 and negative 1. So this simplifies to x minus 1 squared, which is always the same thing as this number divided by 2, right? And so in the same vein, negative 8 divided by 2 is negative 4. That's y minus 4 squared. And then 8, 16, and 1 is 25. To find the center, remember I changed my signs. So the center is not negative 1, negative 4. It's positive 1, positive 4. And the radius, I take the square root. So the radius is not 25. It's the square root of 25, which is 5. Oh, hold on. We might have gotten the answer. If the radius is 5, the diameter is twice that. So the diameter is 10, which coincidentally, just by picking the first one, I got the right answer. Cool. Didn't have to do much work. So 1 is the answer. Number 21, which expression represents the area of triangle ABC? So if I look at the formula sheet, I notice that area is 1/2 base times height. The key for the base and the height is that they have to be perpendicular. So that's where the crux of this problem is I'm looking for two sides that are perpendicular. They tell me that CG is an altitude, and I know that altitude is another word for height, so that's probably going to be pretty key. Yeah. So if this is an altitude, I already know that it's perpendicular, because an altitude is a height. Altitude is perpendicular to AB. So I might be able to use AB and CG as my lengths. And then I know that's 1/2. Cool, that's the same thing as answer choice 4. I'm multiplying AB times CG, and I'm multiplying by 1/2, which is the same as dividing by 2. So 4 is the correct answer. Number 22, this is just one of those facts that I told you to memorize. So the fact that I told you needed to know is that in a right triangle, if you look at the two acute angles, the two non-right angles, the sine of one of them is always equal to the cosine of the other. So if C is our 90-degree angle, that means these are A and B. The sine of one of those is equal to the cosine of the other. So since they're asking me what's equivalent to the sine of B, it's equal to the cosine of the other one, which is A. Answer choice 1. Just 2 more questions. This was the most commonly missed, just because of a simple thing. I know that in a cone, the volume is 1/3 pi r squared h, according to my formula sheet. I know my radius is 2.5. And I know that the height always has to be perpendicular to my base. And this 6.5 is not perpendicular to my base, so that is not my height. My height is this, right there. So I'm going to have to use the Pythagorean theorem to find it. 2.5 squared plus x squared is equal to 6.5 squared. If you're doing test corrections on this, I want you to work this whole thing out. I know that you can solve the Pythagorean theorem. If you do solve it correctly, you'll get x squared is equal to 36, or x is equal to 6. But on your test corrections, if you want full credit, show all the work. So this is 6. So then this is equivalent to 1/3 pi times 2.5 squared times 6. I notice pi is in all of my answers, so I'm not going to put pi in my calculator, but I'll put everything else. I get 1/3 times 2.5 squared times 6, which gives me 12.5. So the volume is 12.5 pi. Answer choice 1. And then last but not least, last question, what's the equation of the image of this line after I dilate it by a scale factor of 3/4 centered at the origin? There's a reason this was number 24. We'll talk about the long way to do it and then the shortcut, and then we'll be done. So I would go ahead and graph this line. I know my y-intercept is -4. I know I have a slope of 3/2, so I'm going to rise 3, run 2, rise 3, run 2, and use my straight edge, draw a nice little pretty line through those points.
Is that where you're going to put something in?
Yeah, so I'm just drawing this line. There we go. Cool. I want to dilate it by a scale factor of 3/4 centered at the origin. So if I remember how to dilate correctly, I'm going to start at the origin. I'm going to pick a point on the line, multiply it by my scale factor, and then regraph it. So if I start at the origin, I think this is a nice easy point to go to. That is, so let's say the origin to whatever that point is, let's call it A. That is 4 down. I'm going to multiply that by 3/4. You can use your calculator to do it if you're bad with fractions. 4 times 3/4 is 3. That means to plot A prime, I'm going to go, instead of 4 down, 3 down. Let's pick another easy one. Let's do, let's just do this one. Up 3 over 4, up 3. Let's do that point right there. So let's call that B. To get from the origin to B, I'm going right 4. So 4 to the right and up 2. If I multiply both of those by 3/4, that means I'm going to go 3 to the right, and 2 times 3/4 is 1.5, so I'm going to go 1.5 up. So if I go up 1.5, and to the right 1, 2, 3, there's my new point. If I go ahead and connect these new points, we'll do a better job in a second. If I connect these new points, I'm going to get this line right here. One thing I notice immediately is that these lines are parallel. They're going to have the same slope. So 1 and 2 are out. And then it's a matter of what's my y-intercept. Well, my y-intercept moved from -4 to -3, so the answer is 4. It's kind of the longer way to do it. Here's the quicker way. This is whenever you dilate a line. Actually, you know what? We'll save the quicker way for another day. we'll do a lesson on that. So we'll stop there. Those are the multiple choice answers. I will work on for response next, and we'll move on. Good luck.